There we go. Okay, good evening, everyone. This is the maybe fifth or sixth meeting of the Dubai Architect User Group. Today we have with us the amazing, legendary Carl Brundage to talk about LDV and data migration with Salesforce. I'm really looking forward to this session. If you're not part of our Trailblazer community group, please subscribe there. And we also have a WhatsApp group for all of the Dubai user groups where we post the events there. If you're not part of that WhatsApp group, feel free to just drop me a message and we can get you added. And then we are planning a few more events over the summer, so keep an eye out for those. So that's pretty much it in terms of announcements. Carl, I will hand it over to you.
Perfect. Thank you. All right, so today we are going to talk about a Salesforce Data Odyssey. And if you haven't participated before, this is going to be modeled after the Choose Your Own Adventure books, where you'll go, I'll present the scenario, and there'll be a spot where I need your input. You're going to help make decisions on what we should do in our scenario and how we move this forward. Sometimes those will be the right decisions. Sometimes they may not go in the right direction. But don't worry, we're going to get back on track and see how we can deal with some very large data volumes. And like any good scenario, we have something that's going to be based off of real life. So in this particular example, we need to do an ongoing data extract. Our customer wants regular full snapshots of key objects that come out of Salesforce. We have a mix of 40 different standard and custom objects. So things you might be familiar with, account contacts, maybe some things you're not as familiar with, account contact relation, email messages, attachments, social posts, as well as some custom objects. But the trick, and I always throw in a trick, is across all of these objects, we're dealing with 1.5 billion with a B records. So we think about kind of the object distribution. Our smallest objects are around 100 million records, up to some that are even 350 million in size. So that's what we have to do. We have to think about how are we going to, as architects, handle this challenge. So here's the first one to get us started, a nice easy one. So my question to you is, how should we get help? How should we get help on this particular topic? A Google search, phone a friend, or ask a community. So now what I want everybody to do is to go to the chat and put in what they think, A, B, or C. Where should we start? And I'm going to kind of look and get a consensus from the in the chat as to what we should do next. All right, ask the community is looking like a popular one. So we're going to ask the community. If we go and ask the community, well, unfortunately, we just get a link to the Salesforce help document on Sockwell and a request to mark this as the best answer, right? So sometimes the community is helpful. Sometimes the community for more complex things doesn't always lead us in the direction we want. So if we were to go back, well, we could, pick a different path. So in this path, let's phone a friend. Hopefully you have a CTA on call, but unfortunately, all circuits are busy. So please try again later. So that leads us to only one option. We're going to go and we're going to do a Google search. And what ends up happening for us is we hit on something that seems kind of interesting, a concept called Salesforce Well Architected. And what this is it's prescriptive guidance for architectural thinking on Salesforce. And if you're not familiar with it, the link's down at the bottom, but definitely search that out because it's going to give you some best practices, some examples of patterns and anti-patterns. And I think that's helpful, knowing what not to do on Salesforce, from the experts. So it's very opinionated about this is what good looks like. And it's organized to help you build trusted, easy, and adaptable solutions. All right, so if I were to summarize it for you, it really breaks down into these three components. We're looking at trusted solutions that are secure, compliant, and reliable. We're looking at easy, and don't think easy as in it's easy to build, right? Because we know as architects, sometimes it's hard to build, but we want an easy solution that's simple for our users, it's automated, and it's engaging. And then last but not least, it is adaptable, something that is resilient to faults and built of different pieces. So my next question then becomes, where should we look? What do people think? Should we look under trusted, easy, or adaptable? So you can put one of those choices in the text box. the chat box. So where should we dig deeper? All of them? Okay. That's kind of an architect cop-out answer, right? Adaptable. So I'm going to take us in a slightly different direction. I'm not going to start with adaptable here. I'm going to start with trusted, because I'm thinking about that last piece. A trusted solution protects your business stakeholders, and reliable to me is something that operates efficiently and dependable under a range of conditions and fails gracefully. So if we start thinking about large data volumes, well, yeah, we're going to have a lot of different conditions that we have to work in. So if I were to drill a little bit deeper, Salesforce, if we think about some of the events they've had architect sessions where you can help build a solution within groups. The QR code will take you to the one on reliable. But the idea is there's areas under each of these. Availability is about risk assessment and failure mitigation. Performance is about throughput and latency. Scalability is around optimizing your data model, data volume management, so long and short-term strategies, as well as scale testing. So of these three things, you kind of see how we're drilling down. We started with well-architected, we went trusted, we went reliable, and now we can consider availability, performance, or scalability. Which one of these three should we go into the details on? What do we think? Available, performant, or scalable? And go ahead and put your chats in. The last two, so scalability. All right, I'm getting a consensus around scalability. And yeah, that's what we would go and look at. And what was provided in that QR code is Salesforce, and these are available on Well Architect as well, have some questions you can ask. And we think about, do parent records have more than 10,000 children? Are there instances of more than 10,000 records being owned by the same user? Is there a data archiving and purging strategy? And is that being followed? So which of these questions do we ask? A, B, or C? All? Well, let's think about it. Go back to what are we trying to do? We're trying to get data out of the system. Is parent-child skew going to hurt us in this situation? Probably not, because we're not looking at updating or changing or querying records. Do we have instances where more than 10K records are owned by the same user? Okay, ownership skew. Again, selecting things out, probably not if we were doing sharing recalculations or changing something. Purging strategy, well, yeah, that's nice, but again, that's, having less data would help us, but that's not going to help us get the data out. So guess what? It's kind of a dead end, right? Salesforce, well architected, has a lot of different pieces, but kind of that logical path we went down to doesn't help us in this particular situation. So what I've done, I've said, okay, we had some places where folks had said, let's look at other areas. If I go through and I pull out what well architected has to say about large data volumes, so trusted, reliable throughput says always use bulkification, so carry out objects against collections. Well, okay, that's more from a programmatic perspective. Easy, automated, clear logic. So we think of the easy, the automated, and clear logic. It says bulkify all data operations, including SOQL. Okay, again, every data operation should be carried out against collections. Again, thinking more from the runtime perspective. Easy automated data integrity. Large volumes or complex data operations can exceed automation transaction limits. Yeah, we will have limits to deal with, but doesn't really make a whole lot of sense. Adaptable. I know somebody said that before. Resilient. There is a tool, manage bulk data load jobs. But all in all, Salesforce well architected doesn't have as much about our particular scenario as we might like. But if I had to summarize the trend or the thing I'm thinking about now is use bulkification, right? That's the message that's coming through to me loud and clear. So for us, if we're going to think about our task of getting data out every week, getting lots of data out every week, what should we think about from a bulkification perspective? And I will give you a helpful assumption. We have an external orchestration system / integration platform. And for this one, nobody's allowed to say all, okay, in the chat. I want you to pick A, B, C, or D. I'm gonna force you to make a choice. So go ahead and tell me what you think we should do. All right, everybody's going through the Salesforce APIs. So I think that makes sense. Things like change data capture and platform events, good for real time, good for streaming, but not necessarily going to help us with this bulk data. And there's definitely some reasons we should avoid weekly data export, even though it could be helpful. So we'll skip weekly data export and we'll go right to the APIs. So from an API perspective, right, we have probably 4 things we can consider. We consider REST, SOAP, bulk, or bulk 2. I don't think metadata or tooling or any of those other ones would help us in this particular situation. So what API do folks think we should start with? So 3 for bulk 2, a couple for bulk. So there's a REST. All right, I'm going to take author's liberty and I'm going to go to REST or SOAP first, because you know what? I'm going to kind of lump those together. And if we think about it, we have 1.5 billion records. REST or SOAP, generally, we're going to get out 2,000, maybe down to 200 records. Sometimes it could be fewer if you have really wide objects in it. So if we just do quick math on that, we're going to use 7 million API requests. Now, I've been in some orgs that have a lot of API requests available, but that's a lot of consumption to think about. The other angle we could think about it is if we were going to take 1 million records, or excuse me, if we're going to take 1.5 billion records and we did it at a rate of 1 million records per hour, that's 1,500 hours. That's 62 days of execution time. And I don't know about you, but 1 million records per hour doesn't sound too bad. That sounds like fairly decent throughput. Maybe you can get it up to 2 million, 31 days. How are we going to do a weekly extract if it takes 31 days of runtime? So REST and bulk aren't really going to help us here. Or excuse me, REST and SOAP aren't going to help us here. I saw some other suggestions for bulk and bulk 2. So let's look at those. They're similar, but they're different. So if we think about bulk, the operations we go through, it's the one that's been around for the longest. We're going to create a query job. We're going to create a batch or batches with the actual query. So the first part's just a job. The second says, I want to select these fields from account. We can manually do some optimization. We can control some different behaviors with it. We then close the job. It processes and we get a set of result sets that come back, and we get one or more and we have to process all of those. Bulk 2 is a little bit more streamlined. We create the query job with the actual query. Salesforce does the optimization. We don't have as much control there. And then we get results back, but the results are done through a pagination method instead of, you think, a collection in bulk of different result sets. So I'm going to go through and I'm going to say, I saw some options for bulk 2. So let's do that first. So bulk 2, it's working fairly well, but then the email message runs. So it gets accounts, it gets contacts, and then email message fails. And then every other job that we try after that fails. So what do you think? What error did we hit? Why did it occur? So this one's open-ended. Now you get to put in some essays. So, what do you think happened here when we got the email message that caused our system to fail? And if you're not sure, it's okay. Wager or guess. What's different maybe about email message compared to account or a contact? So payload size, you're on the right track. So might not support it. Attachments. Okay, so attachments is interesting. You're not actually going to get the binaries out with bulk or bulk 2. You can only use REST to get out the actual binary fields. So it's a good idea, but it wouldn't be attachments. Heap size. So One of the things you need to be aware of with bulk 2, especially when you're querying, there's limits that come into play. And the limit with bulk 2 is around the stored file size. So you can have 1 terabyte of stored files. Well, guess what's unique about email message? Email message isn't like the other objects where each record counts as 2K storage. Email message counts based off the actual size of the HTML or text email that's stored in it. So it can be, even though it maybe only has 100 million rows, it can have 1 terabyte of data in it because every email message, if it's a threaded reply, that whole back and forth gets stored in it. So that's what happened. We hit our 24-hour bulk 2 query storage limit of 1 terabyte. So now any job we run, it's going to say limit exceeded and it failed after it. So what should we try next? Well, bulk 2 didn't work. Let's go and try those options with bulk. So we ran it with bulk. Hey, guess what? We had a lot more successes, for at least for our smaller objects. 1 million to 10 million sized objects, those succeeded. But all the larger ones, over 10 million, failed. So again, what do you think happened? What is the error that we encountered? Why are these jobs failing? So per job limit. Yeah, you're in the right idea. So we are encountering limits again. Batch job limit. Ooh, interesting. I didn't say anything about batches yet, but you're on the right kind of solution for now. What do we do? So if you're not familiar with bulk, remember where I said you had optimizations you could apply? Out of the box, if you don't optimize, everything in bulk is going to run as one batch. So when it queries, you can get back 1 million records in a reasonable amount of time, but you're not going to get back 50 million records. Your queries are going to time out. It's going to take too long. Your batches are going to fail because of timeout. So what we have to start considering is how the way it processes. So let me go back one. Let's look at, what goes on with the bulk processing. So you submit a query, select all these fields from account. Salesforce is going to execute that. It's going to say within 2 minutes, that query has to start executing, or it's going to fail with a query timeout. Once it executes, it's going to try and retrieve the results. So when it's pulling back results, there's a couple of things that has to happen. The results have to be under 1 gigabyte in file size or retrieved within 5 minutes. If either of those things are exceeded, if it's over 1 gigs or it takes 5 minutes in a second, it's going to mark that batch as partially completed. And it's going to cache the results and it's going to come back and it's going to try again. So what it'll do is it'll try after 30 times, and then you end up with a fatal error that says retried more than 30 times, this can't be completed. So if we think about the smaller objects, select 10 million records from account, well, query executes in 2 minutes, it takes 5 minutes, it gets a chunk of them, stores it, does that 30 times, and we get all 10 million. Those larger objects, though, we retry more than 30 times, so it can't move forward. So what can we do about it? Well, this is where we have to think about a different concept using PK chunking. So the first one can be the smooth. There's only one batch. This other one, we have to get chunky. What it's going to do, it's going to look at the primary key inside of a particular object. So it's going to look at the account ID, and it's going to break it into smaller chunks based off the record ID. And what happens is whatever query you submit, Salesforce appends to it additional where clause that says where an ID is between this range and that range. And you have some control over the chunk size. You can pick something up to 250,000 records. The default is 100,000. You can go smaller, you can go larger. You can tailor that based off of what you need. So, all right, that sounds like a good idea. Let's go ahead and rerun everything with bulk with PK chunking. So all chunks all the time. Guess what? Some of our jobs still fail. Now what's happened? We thought we were onto something. We got around the timeouts. So what do we think? Not all objects support it. There's a limit on the batches to process. The batch sizes are approximate. or the object definition changes from job submission to batch execution. So what do we think? A, B, C, or D? Get some A's, some B's. Who else wants to wager a guess? Don't worry, we're not gonna make fun of you if you guess the wrong answer. It's a learning experience. A, B, B. All right, so we're kind of evenly split between A and B, B. Guess what? All of these are a reason that a job can fail. So it's absolutely true that not every object supports PK chunking. You can go to the help article and you can see which ones support it. The limit is generally on the standard objects. There's not there's a decent list, but not an exhaustive list of standard objects. All of your custom objects will support it. I'm going to go to C. Batch sizes are approximate. Even though you say 250K, you might get a little bit fewer. You might get a little bit more records. But again, that's generally not going to cause it to fail. If you have a very long running bulk job, if you go and you delete fields or you change field permissions between when that job starts and when a batch runs, it will absolutely fail and say the object definition has changed underneath me. I can't find this field anywhere. But for our particular scenario, the one that is affecting us is B. Because what you have is you have a limit of 15,000 batches per day. And that's across all operations with bulk. So that's insert, update, delete, and query. So even though we're using this to query, if the customer is doing a lot of other integrations or moving data in and out, then that will take up batches as well too. I have this as a hardish limit. There are certain scenarios where temporarily Salesforce can increase this. If you're doing a data migration, you're moving it in, but you are not going to get this bumped up every day to 30,000 batches. So think of it as a hard limit, but know that if you have a one-off activity or something extraordinary, you can communicate and talk with Salesforce and get it bumped in temporarily. So what we have to think about is how are we going to balance this across all of our job types? It's a matter of performance versus usage. We saw places where bulk made sense and worked. We saw places where bulk 2 made sense. So what do we have to do? Well, we have to use teamwork, right? We have to make use of bulk. We have to make use of bulk with PK chunking, and we have to make use of bulk 2. And these are just kind of guiding principles or things I've found of where it makes sense. If the object is queryable in a single batch, so those examples were under 10 million records, and it's a lightweight object, and I'll talk about that in a second, bulk is a pretty good choice because it doesn't consume a lot of batches. It only counts as one batch, and it finishes in a reasonable time. If you are a standard object where you need that customization, you need to set the batch size, you need to set it to 100,000 or 150,000, that makes a lot of sense. It's things like account or case. If you have those very heavy standard objects where they have a lot of text fields or long text fields, things that are going to hit your bulk 2 stored file limit, that makes sense in bulk and bulk with PK chunking, so email, message, and live chat. Bulk 2, standard and custom objects with basic optimization. What bulk 2 does under the hood is it's essentially bulk with PK chunking, but a fixed size at 250K. That may not meet every scenario that you have. So it's a place where you can definitely experiment and see which standard and custom objects make sense. Things that are lightweight. So if we think about account contact relation, it's account ID, it's a contact ID, maybe there's a couple of custom fields, right? Not a very wide column. That makes sense for bulk 2 because it'll be very fast and it's not going to kill you on your storage. What would be another good? If you're doing anything with history tables, right? Think about history tables. It's an ID, it's a previous value, it's a date, it's the current value. Those things work well because bulk 2, you're not going to use the chunks, you're not going to use the batches, and it's not going to be a very large file that you store at the end. And then the last place, it's kind of your get out of jail free card. If you have large standard objects that don't support PK chunking and you need to get smaller batches because it's timing out, makes a lot of sense there. Perfect. So we're going to take and we're going to use bulk we're going to use bulk with PK chunking, and we're going to use bulk too. So how should we structure this? What should our jobs that we submit look like? Are we going to take and put all the jobs in one object? Are we going to have one job for bulk objects and one job for bulk two? Or do you think we should have one job per each object? So A, B, or C again in the chat. So I see one B. Okay, one job per C, C, C. So the general consensus is C. And I think that's the path we were going to go, because when you submit jobs through bulk or bulk two, one job can only specify one operation and one object. So you can't say, I want to query account and contact. You can say one job queries account, one job queries contact, one job updates case, one job deletes case. So each one is going to be separate. The batches associated with the jobs are only going to contain records of one object, and then the optimization is performed for job. So if we wanted to say account is using a chunk of 1,000 and case is using 250,000, then we would have those separate jobs as well too. Perfect. So we're going to set up 40 different jobs to handle all of our objects. We want this on a weekly basis. When do we schedule it? Do we schedule it, any time of the day or night? Do we schedule it during off hours, or not Friday at 11 p.m. in the org's time zone? So what do we think? So lots of off hours. I put off in quotes because sometimes in global orgs, what is that? When is there actually an off hours? So oftentimes you do go looking for the times where there's the least amount of activity or the least things going, because you don't truly have any off hours. But I'm going to focus on this really oddly specific answer I gave you, not 11 p.m. local time. Why is that? If you're using Salesforce CRM analytics, there's a couple of modes that it can ingest data. It can do an incremental sync, it can do a full sync, or a periodic full. But the way that it pulls all of its data is it's using the bulk API. And guess what happens? If you picked periodic full, that will run a full sync for the first sync that happens after Friday 11 p.m. in your org's time zone. So just if you think about that, we would have a massive extract to pull things into CRM analytics and a massive extract in order to pull things out for our data integration. So again, very nuanced, but if you pick and schedule away from that time, you're going to have better performance because you don't have competing full syncs going on at the same time. So any off hours is fine, but I would say avoid that CRM analytics sync after 11 p.m. So let's just schedule it for 12 a.m. Wednesday. All right, let's go. Our processes are running. Let's see what happens. Well, they just keep running and running and running. It takes us 515 hours of runtime and 5 calendar days in order to complete. So what's going on? I mean, maybe that's okay. Maybe we did well. What about maybe bulk processing has no SLAs? Or, oh my gosh, I have no idea. I'm going to go back and phone a friend and post in the community again because this seems crazy. So what do we think? A, B, or C? I have no idea how everybody's being honest. We've reached the honest part of the presentation now. I love it. Yeah. So, I don't think it's okay. I wouldn't go and give a speech about how I got out 1.5 billion records in 515 hours. That's not too great, right? It's absolutely true that bulk processing has no SLAs, but let's get under the hood. Let's understand what's going on. So if we think about all these batches we've created, bulk with PK chunking, bulk 2, they get placed in the queue for processing. Salesforce will then perform those based off of available platform resources. And I think that's important, that it is the entire platform that you're running on, so it's cross-tenant. There is no performance SLA. There's no guarantee around runtime or how long things would take. And we saw before that it's going to run for 5 minutes, retry up to 30 times. It can do multiple batches at once, but over-consuming will result in deprioritization. Because again, cross-tenant, trying to be fair, if you're using too much, you'll be deprioritized so other things can run, whether it's in your tenant or in another tenant. So what does that mean? Well, let's think about some of the things we're trying to query. If we're trying to look at the query for an asset table, this is just an example. You probably have seen the bulk data load page. The idea is it talks about all the things that we've seen, the job type, bulk 1 versus bulk 2, the fact that we're querying, the number of batches that you have. But what it's going to do, you're going to submit this. And from my observation, I don't have an official statistic from Salesforce, is I typically see 30, maybe 40 batches at max executed in parallel. So it does the 5-minute runtime and it retries 30 times. So we think about one batch coming off, runs it. If it fails, it's going to put it back in the queue again, right? So we're kind of have a queuing thing with one object. Well, we're doing multiple objects, right? So what starts happening? Well, we take the asset, we run the batch, times out, we put it in the back. That's kind of a simplified look, right? A more realistic view is it's going to take 30 or 40 batches, not necessarily just from one object, but from different objects that we submitted. So it might take the asset one and the contact one and start putting those further and further back in the queue. So guess what starts happening? You have something that looks like this, right? Where your batches are not necessarily in order. It's not going to keep all the asset, all the contact, all the account. It's just going to take a batch, run it, put it in the back of the queue, take it, run it, put it in the back of the queue. So after a while, you have this mess, right? Of, well, we have these objects, they're coming back, we're pulling it in. Well, this is just 2 at a time. I can't quite go to 30 at a time, but you get the idea, right? What we've done is we've created this scenario where if things are timing out and they're not processing, now we don't know exactly when the blue that related to the account is going to get processed or the purple from an asset. We have what I call the Three Stooges syndrome, which if you've ever seen Simpsons, Monty Burns gets sick. He has every disease possible, but because they're all trying to infect him at the same time, he's invincible. So this is where the retry is your frenemy. Yes, it helps jobs complete. It's great when there's one job, but when you have multiple jobs, everything gets out of order. And I know we're trained to think SaaS and not think about things underneath, but just think about from a database perspective for a moment. If you're querying account and then you're querying case and contact and custom object, if you're doing all these things at a different time, how are you caching these large objects? You're not. You're just knocking each other out of database table cache, because it takes a lot to put 350 million objects in the cache. And then you run a batch and then it goes back to the back because it times out. So if we think about this batch chaos that we have, what should we do? Should we avoid flooding the queue? Should we limit the number of retries? Should we use serial mode, or should we avoid deprioritization? So A, B, C, or D. So use serial mode. Okay, limit retries. Avoid flooding the queue. So we got an A solution. All right. So let's look at a couple of these, because I think they kind of go hand in hand. I think I'm going to start with limit retries, and I'll come back to it. If we think about retries, you can look at it in the UI. You can also do it programmatically from the API. You're going to get a XML result. And what you'll have is you'll have the number of retries. which is the total number of times Salesforce attempted to save results. So if we look over here, number of retries, I'm pulling out the case object. I actually have 335 million here. I've already retried 6,000 times. So you have to start thinking like, what can I reasonably query in 5 minutes? If I took 335 million records in 1K chunks, well, that's 3,400 batches. At the end of this job, it actually retried 7,000 times. So I did 10,500 executions. Like, that's insane, right? That's why this is performing so poorly, because it keeps taking longer for each batch to it takes longer for each job to complete, because the batches are getting strung out for such a long time because it's waiting for some other batch to complete. So if we kind of, well, if I have that result, how should I think about it differently? Well, think about it how many executions you had. Well, if I had 10,500 executions, I probably should have had a 32K batch size. That would have helped me complete without a retry, right? Because if it's retrying that many times, theoretically, you move it down, you're going to have it complete without retry. But wait a second, I only have 15,000 batches. Like, that's using 2/3 of my batches for one object. So again, we can't always do that because we have that limit constraint that we have to think about. So the other option that was out there was thinking about the queue management. And this is a place where we can have an impact, right? Because we can spread out the queue and run each object by itself, or at least minimize the overlaps, right? Instead of saying run all 40 of these things at once, we can break it out. We can say, all right, let's run object 1 case. Let's run object 2 account later on, so forth. Generally, bulk 2 and bulk, they kind of can run okay at the same time, but if you start really loading up the bulk batches, that can be problematic. It ran for 5 days, so why don't we use days of the week as a benefit to us? Instead of running everything at one time, 12 a.m. on a Wednesday, let's run some things on Wednesday morning. Let's run some things on Thursday, Tuesday, so forth. So what we can consider is we can consider the job execution, how long it takes on Salesforce, and then how long it takes us to download. So by just spreading out our schedule, we move things around where we're not running all the objects at once. We cut our overall runtime in half. So we got from 515 to 250 hours just by moving things around. That's it. So we're done, right? Or can we do more? So should we stop at this point, or should we keep digging and see if there's some other areas that we can improve? Oh no, I'm kind of tired. I think that we should call it a day. This is getting hard. All right, you guys want to keep going? Let's do that. So we can think about some bonus points here, right? The way we structure our jobs, it's pretty good if we start the second job after the first job is completely done. So if we run an account to completion and then start case and then start contact, but it might be better if we more tightly sequence our jobs. So we should start the second job when the first job is finished executing on Salesforce, but while we're downloading results. So we can overlap them a little bit because the Salesforce processing is done, but the downloading can take some time. The best thing we could do is start the job when there's still 30 or 40 batches left to complete, assuming that we minimized retries and done the other things. Because now you've put more things in parallel and you can have better performance. So that's some bonus points we could consider. But where else should we look? Should we look at how we download or what we query? And I think everybody wants to look at what we query. So let's do that. So I would ask, if we're pulling everything out of an object, do we really need that? Do we need things like system fields? Do we need the auto numbers? Do we need the formulas? Those are definitely things that if you need to ever restore the data, you're not going to be able to recreate. The answer may be yes, you need things like an auto number, like the case number, but maybe you don't need all the system fields. So every field that you can trim off especially long text fields, will help you out. So why are long text fields costly? Well, there's a couple of reasons. One, it increases the size of the batch, how long it takes to run. It increases the file size. So you're going to hit a retry limit for file size. It's going to take longer to download. And guess what? We're going to go back out of the SaaS world and think databases again. The way that Salesforce holds long text fields is in a separate table. So any of your standard fields or custom fields that you create, it goes in MT underscore data, and that has a variable data type. So that's what you're looking at over on the right. Org1, object1, this particular field definition has a text field, it has a date field, it has a numeric field. So all the fields that it's querying is going out of one table until you get to long text. So long text is in MT clob, which is a separate table for long text fields. So now you have to do another database join and get all this stuff in there. So again, these things start adding up. Are you going to see it at 1 million? No, you're definitely going to see it when you're at 500 million. So that's the difference. So if we think about our fields, we can impact it. But I'm going to go to the other answer as well too. How we download the results. Once we've completed this query, we could be looking at a lot of data. So those 335 million cases, the files that are produced in Salesforce is 2.2 terabytes. So think about that. We're going to download 2.2 terabytes. So how are we going to do that? Each batch, because it retries, it can have up to 15 files. So those 10,000 retries can look at 15 files. So we're looking at hundreds of thousands of files we have to download. If we just wait for the job to complete in its entirety and then download, well, in my example, the case took 33 hours to execute and 45 hours to download. So what is that? 78 hours of execution time for one object. What if we didn't wait? What if we thought about when a batch completes, we download the results? What does that do? That moves more things in parallel. So now our processing is in parallel. We're completing a batch, downloading it. What that does is it takes our 78 hours down to 51 hours. So we trimmed almost a third off of that just by changing the way we download. So that was, just a small difference between serial and parallel. So if we think about, the things that we've done. So we took that extract of over 1 billion records across 40 objects. We changed the API, so we're using all the APIs. We've scheduled our jobs more intelligently so that they're not overlapping. We're downloading in parallel. We're to a point where now we have 190 hours of execution time. So 65% improvement from where we started. That's something we want to share with the community about how we got there. So the good news is, hey, our extract is working great, at least until we start deleting data or updating data or doing things that can create locks inside of the system. But guess what? That's going to have to wait for another edition of Choose Your Own Architect Adventures. So at this point, I think we can open it up if there's some general questions or comments or things you want to dive deeper in. We can have that type of discussion now. But thank you for going on an adventure with me. Hope you enjoyed it.
I got a question, Carl.
Sure.
Go ahead. Sir.
Thanks. So I was thinking, will the skinny tables help on any of these scenarios for us?
So skinny tables, if we think about what it does inside Salesforce, the standard fields in an object are stored in table A. Custom fields are stored in table B. So the underlying in the database schema, there's two separate tables. So a skinny table will pull those together in one table. So now you're not doing a database join. However, they're skinny, meaning they don't contain all the fields. You have a limit. I want to say it's 100, but maybe it's changed. But there's a limited number of fields that you can put in there. If all your fields are under 100 and they fit in the skinny table and you don't have any long text fields, it can help. But otherwise, it's really not going to apply because Salesforce is going to have to go query the underlying actual tables to get all the fields. Usually, when customers have 1 billion records, they also have hundreds and hundreds of fields. And so skinny tables generally doesn't come into play for helping us out too much. But if you have the right parameters, yes, it could help. So good thinking outside of SAS and going back to the database level. I like it.
Carl, I have a question. Do you have a recording of the previous one? There was like a previous episode to this, right?
Yeah. I have to remember where we did it. It was either Apex Hours or it might have been the Odyssey Data Architect Forum, but there's definitely a recording of edition 1 where we talk about how we are going to query certain things and get out data for archiving. So it is recorded. I just don't remember off the top of my head exactly where.
Gotcha.
But we'll find that as a follow-up.
Awesome. And just trying to think outside of the box, what if we like change the overall architecture to help solve this? Like, I don't know, we introduce Heroku, use Heroku Connect to like push all of the Salesforce data kind of via CDC or whatever to Heroku, and then pull it from Heroku instead of Salesforce. In real life, would you see that kind of solution as feasible?
I would think, and what usually ends up happening is there's some type of archive solution, right? Because if you're dealing with this scale or this volume, it's too much in Salesforce for not to have other problems, whether it's reporting or list views or something else. So usually the discussion becomes, great, you have this, but why? What are you needing all this information for? What's interesting is, you may also think, oh, data cloud, this could be a place where we can archive our data and put it in data cloud, or we can use data cloud. Well, guess what data cloud uses bulk too. It's using the same APIs to pull out the data. So again, you're going to face the similar type of challenges that you have to overcome. Once you overcome it, yeah, okay, it's in data cloud, great. Now we can delete it, and then you'll be able to have the better performance or better integration, but you have to at least get over the hurdles the first few times.
Cool, thank you.
Other questions out there? So we definitely did it for Apex. I did it for Apex Hours, so that is out there. I'll put that one in the chat. So to prevent the lock contention issue that encountered in parallel mode, is always advisable to run in serial mode. So one of the things that's interesting is we didn't encounter the traditional Salesforce lock contention. So we did not encounter those things where if you're trying to update records in parallel or delete records in parallel, or even insert, where it says, could not lock record because you're updating a case and it needs to lock the account of contact. We're getting more query timeouts because it's taking too long to query the data. So in our case, serial mode is really running a batch size of 1, because it's not, that would be the equivalent of it. And if you have too much data, that's going to time out. When you're running things in multiple batches, your batch size is going to kind of be your parallel mode. If you think about it, like that's going to query this set, this set, this set, this set, this set, with those where clauses of one object at multiple times. So when the batches start retrying, that's where then, all right, if this gets put on the back of the queue and another object comes in, then yes, from a database perspective, it would knock it out of the queue. So that's where we talked about trying to limit retries, trying to get everything to execute within 5 minutes, so that you have all the data, it's done, it can move on to the next batch, and you don't have that place where you're just knocking everything out of cache from a database perspective. What other questions do we have out there?
I have one more. What was, maybe I missed it, what was the actual use case of like why you wanted to extract data? Was it for like a full org backup, or?
I didn't give a particular reason in the scenario at the start, but the experience this was drawn from was full backups for backup and restore. So from a recovery perspective, business continuity perspective. So something that they wanted on an ongoing basis that had to be tuned to 190 hours instead of 500 and some hours to start. And there's reasons you can say, well, why don't you do more incremental logic? Incremental is great until you do something like change the definition of a formula field. Now all of your data changes, but you don't get an incremental update to that. It doesn't tag your records. And when this data is being fed to other systems, because you're not always using it for backup or store, you can use it in your data lakes, your data warehouses, you want to have that accurate picture of it. So it's a balancing act between what's your frequency for full backups versus how long you can rely on incremental. And I think we see that in platforms like CRM Analytics, where you have full, you have incremental, and you have periodic full. And more often than not, to be safe, you go with periodic full. The other place it comes in is if you think about cross-object formulas. Well, I'm not going to get a modified date on the child in the cross-object. The parent's going to change, but the formula for the child changed, or the value for the formula changed. Again, there's places where you don't always get that incremental dates that you can rely on. So it just depends upon your underlying use case and what works with it. What else? Don't be shy. Happy to. If there's something that didn't make sense, let me know, and I can explain it again. And I can think about next time, what maybe I change in the scenario.
Hi, Carl. Just a follow-up question on my previous question. Can we also consider archiving the data when we are dealing with this large data volume?
Yes, I think data archiving makes perfect sense in a situation like this. And I would talk to my customers one of two ways. There's different types of archiving. Are you archiving for compliance reasons, performance reasons, something where it's like, I just need to keep the data, but I don't need to operationally use it. And that's where you can take it out and you can put it on the side and it sits there. And if you have a legal request or some reason to go pull it, an admin or somebody can pull it as a one-off scenario. The other situation that I've encountered with customers is we just have too much data for Salesforce. Yeah, we've hit a limit, like more than 30 million files. We need to remove this so Salesforce performs the way that we want, but we also need to retain it for operational use. So that one's trickier, right? You can't take that and you can't park it in a system that only an admin has. You have to have a way to visually then provide it back to users so it's outside of Salesforce, but you can see it. And I've built those solutions before. I have commercial solutions at 07 that does that. The Heroku solution that was mentioned before, something like that makes sense. Maybe big objects, but again, if you have files or you want a similar user interface for your users, there's some limitations there. So you have to kind of figure out, why are you archiving? Is it just to see the data, or I need to use the data, and then come up with the right solution, whether it's build it your own or something commercially available in order to meet the needs.
Okay. Thanks, Carl. Appreciate it.
And in this particular scenario, it's drawn from, yes, this customer I've done archiving for as well too. And while it hasn't reduced the size of some of the largest objects, it's kept them from growing from another 150 million rows, right? So that 350 would have went to 500 million, but we've maintained a steady level of volume by some aggressive archiving. So yeah, definitely think about it, and think about it early, because it's hard once you've waited too long to start archiving, because you have a pretty big hole that you have to dig out of with performance and queries. And you didn't build that data volume in a day. You're not going to eliminate the data volume in a day.
Yeah, it makes sense. Thanks, Carl. And
my pleasure.
For the PK chunking, is it advisable to enable the PK chunking in advance, or can we enable the PK chunking or consider enabling the PK chunking for the objects which has more than 10 million records?
So 10 million records is kind of a rough rule of thumb. You can always run a bulk job without PK chunking. You can watch it fail, and then you can identify, why did it fail? Oh, it failed because it retried more than 30 times. So I now know it's taking too long to do it. But what I found is it's rare that, unless you have a very skinny object, only has a few fields in it, that it's going to succeed with bulk with just one batch. So you kind of start gathering an architect sense for these things, the more you do it, to say, I'm probably just going to jump right to PK chunking on this object because I know it's going to fail otherwise. But no, you can definitely let it fail once, because it's only one batch. It's not going to hurt you for the limits. If you do an oops on PK chunking and say, oh, I want a batch size of 10, you can very easily blow through your whole entire limit in one job. So there's some risk. You can definitely try it first without it, see if it works or not, and then adjust as you need to.
Got it. Yeah. Thanks, Carl.
Yep.
I have one more. So for performance testing, you can use like a full copy sandbox and inform Salesforce in advance. How useful would it be to do this exercise in a sandbox before doing it in production?
Somewhat and somewhat not. What is interesting about it is the things that I do in sandbox usually have seen a little bit worse performance than production in the full copy sandbox. Things don't behave exactly the same way. So if I know it's good enough from a performance perspective in a full copy sandbox, then I'm pretty comfortable in production. However, rarely do customers replicate their production load in a full copy sandbox. So for query, okay, if you're just querying and you're the only thing running in bulk, that's great. But if the customer has all these other integration processes that also are creating batches and you can also compete with, you need to make sure that's replicated in the full copy sandbox, or you're not testing against real world conditions. If you're doing an update, a delete, and insert, you don't have the simulated user load in the full copy sandbox to know, do you have a lock issue? Are you doing something in the user interface where a customer makes an update and you propagate it to 12 different objects and it locks them all for 10 seconds? Well, now your bulk jobs that worked great to delete or insert in sandbox, they're going to have problems in production as well too. So it's a question of, what exactly are you testing and what are you trying to get out of your test? I don't kind of breathe a sigh of relief until I've also done a few runs in production for that customer to say, yes, there's some unique things about your production environment that aren't replicated in that full copy sandbox. Now that we've gotten through those hurdles, I feel good about this ongoing process. Maybe that's been your experience or not. Like it just depends upon what you're trying to test.
Cool, thank you.
All right, don't be shy, or we're going to have last call for questions if there's anything else. All right, so I'm going to ask a question. Do folks like this format? Do they like being able to participate a little bit? Even if you don't know the answers, you can wager a guess. Hopefully it's a little more engaging than me just talking for an hour. You have to think a little bit.
Hi, Carl.
Yes.
Yeah, I just have one question. Now, some of the records, suppose if they are failed errors, then how do you suppose out of 1 million, suppose 10,000 are failed, then how do you handle that, the error, basically error handling?
I like that. Thank you. If we go into a batch, if you look at a batch through the user interface, if you click, I'm going to go back a slide here. Let me find it. And I know this is a little bit hard to see, so try it inside of your own org. But what happens down here is you get all of your batches, and your batches will have this link that says view request, and when it finishes, it'll have a link that says view results. View results is what you're going to download. But if you do view request, which you can do it through the UI or you can do it through the API, it will show you the actual query that was used for that particular batch. So if a batch were to fail, what you can do is you can iterate through all of your failed batches, get the queries, and then submit another job. You can submit a job and you can create batches manually that say, I want this, 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 and this, these 5 batches that failed. So you can be very intelligent about your retry and only retry the ones that failed with the actual query that was used by looking at the results. So that way, instead of running 1.5 billion records next time, you have to run 1 million or some smaller number. So yeah, you definitely can put some pretty sophisticated error handling and retry logic based off of looking at the batch query that was used and then the result of each particular batch. And you probably can't see it here, but you have statuses in progress, not processed. It'll tell you it failed or and the reason why if it retried more than 30 times and so forth. So you'll have a lot of information that you can use to be intelligent with the retry. No, we didn't talk about that in the scenario, so that's a good addition. Might add that as another question at the end. Oh, 5 of your batches failed. Now what do you do?
So Carl, do you know any of the commercially available products like ETLs do these type of smart checks?
I don't know. It's an interesting angle on it. Definitely, I see them as platforms, right? That if you have the intelligence to know how to make the platform work, you can do some pretty cool things with it. I'm not sure if they go to this level of looking at retries and intelligently sizing things. Maybe it's a good new product offering we can go build. All right. Well, thank you for the opportunity to come and present and share that adventure today. It was definitely fun putting it together and putting some twists and tricks in there. Hopefully there's something you took away that you can use in the Salesforce projects that you're architecting.
Yeah, thanks a lot, Carl. It was super interesting, and I'm personally looking forward to episode 3 of this. So yeah, maybe we can have you on later for that. But yeah, thanks a lot for taking time out of your busy schedule. Really appreciate it.
My pleasure. Thanks for having me.
Okay, thanks everyone.
Thanks, everyone.
We'll see you next time.
Thanks, Carl.
Have a
Thanks
good day.
all.
Take
Bye.
care.
Bye.
Thank you.